Hello, I am a fourth year student of electrical engineering and computer science. It's a double major, and it takes 5 years. So I graduate next year, and I'm trying to prepare for graduate position job applications by practicing LeetCode. And along the way, I've actually really started to enjoy it. I am very much a beginner, I would say. I've solved probably only like 40 problems, and I've needed help for a lot of them. And I thought that it would be kind of cool to document my journey as I go through solving the NeetCode 150 roadmap. And so this is me solving the balanced binary tree problem. I have not read this problem before. I don't know anything about it. And yeah, so I'm going to get right into it. My goal for this is to record as much as I can of my journey with learning this and be able to look back on it, see my progress, and also get good at explaining my problem-solving process for unseen questions, and maybe help people also understand problems if possible. Otherwise, yeah, I think it'll just be a good exercise. So I'm going to go ahead and jump right into it. So I'm going to start off with reading the problem. So given a binary tree, determine if it is height balanced. So, okay. Seems relatively simple, as in there's not much in the problem statement. But I'm not sure what height balanced means, so the depth of the two subtrees of every node never differs by more than 1. Okay, so the depth of the two subtrees differs by. How is that balanced? I wonder. But okay, well, okay, so this would be height balanced because this side here is different by this side only by 1, and this is not balanced because this side here is what's it called? Okay, here this is balanced, but then once we get up here, this height difference is now much more than 1. So let's see. I guess what's the, like, I'm trying to consider the smallest possible case here. I guess it'd be either this one, or I'm gonna bring up OneNote so I can draw my little thoughts, and hopefully you can see it. Okay. So I'm gonna put it on the code side right now because I'm not writing code yet. But I'm trying to think of the smallest possible case here. So I guess that would be like this. Actually, I can probably look at the number of nodes. Okay. So 0 to 5,000. Interesting. Also, I am drawing with the mouse. I do have a pen somewhere, but I just don't know where it is. So that's 1. Okay, well this is height balanced. This is height balanced. This is height balanced. This would also be height balanced. As I'm drawing this out, I'm kind of seeing that it is kind of giving like maybe like a breadth first search kind of vibe to it. And that I'm expanding the nodes and looking down, but it could be just the way that I'm solving this problem, or the way that I'm writing this out is confusing me, so I don't know. But that's just my first thoughts. Okay, so now if I go down 1 level, then it's no longer height balance. And it's because if it was height balance, this would need to be here. Let's just call that X. And if that's missing, then we now have a difference. Sorry, I need to check something else. Is the depth of the two subtrees of every node never differs by more than 1. Okay. Of every node. Is that height balance? So, okay, that's the same. Alright, sorry, that's height balanced, that's height balanced. Is this height balanced? No. And why is that? Because the depth of this is going to be 3, and the depth of this is 1. So it's not. And back to like a simpler case. Yeah. And this is like a hypothetical. I'm gonna put that back. So that's maybe in it, maybe not. So if it wasn't in the tree, we'll use blue for considering the case where it's not in the tree. So this is height balance if it's not in there, because L equals 1, R equals 0. And then when we go down, L equals 1, R equals 0. So maybe we do actually need to go from the bottom up. So if we get to the leaf node, okay, L equals 0, R equals 0. Okay, so that's alright, so we can go up. L equals 1, R equals 1, sorry, R equals 0. That's alright, so we can go up. And L equals 2, R equals, okay, so what's R? We have to now go down. Well, if that's not in there, then we have R is going to be equal to 0. 2 minus 0 is greater than 1, therefore not balance. Okay, so it seems like we can like divide and conquer this one, I guess, is the no, not divide and conquer. Well, kind of. It's just recursive. So I'm gonna make a slightly more complex case. 3, 4, 5. Can we still see what's going on? Yes. I'm gonna make it a bit bigger, just so I can draw a bit more. And make it a bit bigger on my screen. Does that work? Yes. So, okay, and I'm gonna delete all this. I guess I could just select it, Control V. Okay, great. And I'll move this. Also, I am a very busy person, so deep apologies for the lack of editing, but I would just not do this if I had to edit it, so yeah, plus I feel like doing it raw kind of gives a better, like it puts me under the pressure more, I guess, which is good. Anyway, back to what we were doing here. I want to see if I can like discover like an if these ones are unbalanced like this. Okay. Yeah, this is what I'm looking for. So we'll start we'll go okay, so this is our DFS boilerplate. And I don't know why I use brackets, because I am going to be writing in Python, but whatever. Alright, so we start here, and I'm just going to draw out the stack as well, because that kind of helps me visualize recursive algorithms. So here's our stack. Alright, so we're going to put 1 into the stack. That's our root node. And we're going to put 2 into the stack. And then we'll put 4 into the stack. And 4 is a leaf node, which is our base case. Okay, well this is interesting because I'm not sure how to break out of this yet. Okay, yeah. No, actually, I don't know how to break out of it yet, but I'm not gonna worry about that yet, and I'll get back to that. But, and I also don't really know how to do this stuff iteratively yet, which is something that I do want to learn, because, yeah, but I'll get to that later. Okay, so we're at 4, node 4, and we can pop that out of our stack, and we see, okay, 4 has left 0, right 0, so we're going to be returning 0, and so far so good. And then we're at 2 now, and we're going to be getting to this part of, so okay, I see now. We're going to want to save the height of the left node, which is L equals DFS L, plus 1. So, okay, we have height, and that is if there is a left node. Okay, well, I'm not gonna write that out, but I did say it out loud. If there's a left node or if there's a right node, otherwise we're going to be setting those values to 0. Okay, and if L minus R is greater than 1, we're going to be somehow setting something to false. But I don't know how yet, but that's okay. Okay, so now we've got 2, and we're going to the right subtree, so we got 5, put that in the stack. Going to the left of 5 is 6. Okay, 6, pop 6, we got 0. And then 5, we gotta expand the right side, which is 7, put that on the stack. And then we put 8. Okay, then we get 0 from 8. And we get 1 from 7. And then we get 2 from 8, 7, 5. And we have a 1 from 6, so we have 3 here. Okay, so now, I should say h equals 3, but it's a little hard to write things with this. Oh my god. Okay, and now, we can, yeah, like, cross that off, whatever. And h equals 1. So now here, h equals, 4. Oh, here we have to do a comparison. Well, we can already tell 3 minus 1 is greater than 1, therefore false. Okay, but let's just say we didn't break out of that, let's just keep going. And I can probably just have a result global variable and just go up to the top, but this is a little bit inefficient. But it shouldn't matter because it won't actually change the time complexity of the actual code. Like, it won't change the time complexity because we're only calling a constant number of nodes, because in the worst case it'll always be what is the time complexity of this? So we have I guess we have like n nodes, and we have to go to all of the nodes. Oh no, okay, how many nodes do we have? At most we have height n log n nodes, so that would be n log n, I think. Yeah, because at each level there could be a maximum of log n nodes, so yeah. I think the time complexity for this would be n log n, but I'm not totally sure. I'll have to fact check that. But anyway, okay, so we have a height 4, okay, and then here we check height 1, and 4 minus 1 is clearly greater than 1, so false. So I think what I'm gonna do is similar to the previous problem I did, the diameter of a binary tree, where I'm gonna keep a global variable, and I'll call it is balanced, and then I'll do a DFS, and our base case is if if not node dot let is not. Alright, return 0. And then we'll do L is equal to DFS node plus 1 if, oops, node dot left. Node dot left else 0. Alright, equal DFS node dot right plus if node dot right else 0. Okay, and then if abs L minus R greater than 1, is, well, is balance equals false. And we're going to return the height, which is going to be L plus R. Return self-drivers. And I think that this should work. I think it should work. I'm just trying to think of any edge cases here. So what would some edge cases maybe be? Probably like if there is only one node, it should work. I can't really think of any edge cases, to be honest, for this, because since it's recursive, it should cover all of them, I think. I'm gonna go ahead and run it and just see. Oh wait, I also just realized I forgot to move the, oh no, I didn't forget. Okay, well, I did get this wrong, and I'm not sure why. I got some right, but this one wrong. So what did I do wrong here? I'm just gonna draw out that one so I can try to debug it. Alright. So we've got 1, oops, I'll go back to black. 1, 2, 2. Gosh, I always forget how to implement these. Whoops, I accidentally just opened Visual Studio. Wait a minute. Okay, 1, 2, 2, 3, 3. No. Okay, yeah, that is how I thought actually that it was written. Okay, 3. Oh, it's just this case. Wait, why didn't that work? It's just this case. I'm not really sure why it didn't work for that case. I'm gonna draw it out though, and then I'll go through my code and try to figure out the bug. That's part of this. Something that I'm trying to get better at is identifying errors in my code. I guess what I should have done maybe is run it through all of the test cases before submitting, like in my head maybe. But anyway, so what's my code say? Just going back to this. Alright, so we've got isval is true by default, and this is going to represent the global variable. Okay, so oh wait, hold on, I see why I didn't actually run it. Okay, now we can see. Okay, well, I do have an issue, and hello. And what am I doing with L plus R? What am I doing with L plus R? Oh, no, I need to be returning the max of LR. But that's still not working. This happened to me last time. And I don't know why. Is it, oh, if not node or not. There we go. I forgot I didn't consider this case because the last problem I didn't have the possibility of an empty tree. So I'm gonna go ahead and submit. Oh yeah, I got it, but it's slow. I'm guessing that's because I use recursion. Or maybe it's because of Python. Oh, yeah, this is what I submitted. What? Yeah. Um, okay, well, why is it so bad? I'm trying to think if I could make this iterative. If I'm thinking about the stack thing, why couldn't I make that iterative? So, okay, put 1 in the stack, and 1's gonna have height 0. It's because the fact that it like relies on the other ones is why I find it confusing to think of it as a stack, because if the it's almost like the top one should be popped last. But then to add the children to the stack, I don't understand like how to go back up, if that makes sense. Like I know how to go down, but not back up. Well, do I need to go back up? Could I solve this problem bottom, like top down? Let me think. So 1, 1, 2, 1. Oh, sorry, 1, 1, 1. I don't know. I think I'm gonna have to look up at some solutions for this part. But yeah, I'm happy that I solved the problem. So I'm gonna go ahead and stop it there, and yeah, potentially I'll look into a better solution. But seeing as I did solve it and I have to watch some lectures now, I'm gonna go ahead and end the video. Thanks for watching, and yeah, I'll be doing more of these. So if you're interested, feel free to subscribe. But yeah, thanks.